Hello, today we're going to start a new chapter, chapter 7, all about polynomials. So this first section is about adding and subtracting polynomials. And to get into that, we have this question number 1. It's meant to be just kind of nice and quick. So circle all of the different terms or things that are like and write the final number that you have of each of them on the blank below. So pause it and you try it first. Okay, so let's take a look at this. Here we have 6 fish, 3 mice, 2 birds. If we're looking at our x's, we have 2 x's in the middle here, and then we only have 1 over here. If there's no number out in front, there's a 1 there. Same thing with our x squareds. We have 1, 2, 3 of them when we combine them all together. And for our x squared y's, we have 5, 3, and 1 more to make 9 in total. While this might seem a little goofy at first, the goal of this is to get used to seeing what is like terms or what are like terms. So you can very clearly see with like the pictures of the animals, like, hey, those aren't alike. I cannot combine the birds and the mice together. Instead, what we have to do is we have to start thinking like that with variables. So x is different than x squared, which is also different than x squared y. Okay, so that's our goal kind of for today is what can we combine and how do we combine it? So to figure out what we can combine and how to combine it, we first need to know what a monomial is. So we're going to use the prefix of mono, meaning one. So it's one term. And that term can be made up of numbers, variables, or a product of numbers and variables. So 3, or 2x, or negative 5x squared y cubed. All of those are monomials. What you can't have is you can't have negative exponents. So x to the negative second does not work. You cannot have exponents in the denominator. So for instance, 1 over x squared does not work. You also can't have fractions for exponents. So x to the 1/2 would not be a monomial. And then the last thing you can't have is more than one term. So for instance, 3 plus x is not a monomial. If you do have something that is only one term, we can find the degree of the monomial by adding together all of the variable exponents. So the degree is really asking how many variables are in that monomial. So for instance, this one here, 2a, this is one term, it's a monomial. How many variables are there? Well, there's 2 because x squared indicates that there's 2 x's. For b, how many variables? Well, there's 0. It's a number, it's a monomial, it's still a monomial, but it's really saying x to the 0 power because that would simplify to just be 1. The degree of this monomial is saying, well, wait a second, there's 3 x's and there's 4 y's. So all in all, there are 7 variables here. So our degree here is 7. So the next one, we have 2 a's, 1 b, and 7 c's. So all in all, there are 10 variables for this one term. Now you have to be careful because we're only looking at monomials. We're not looking at something like a squared plus bc to the 7th. We could not do that the same way. So we'll talk about that in a minute, but these were only for monomials. If we have more than one term, we need to know how to write things in standard form. So standard form here means you have the highest degree first, and then you go in descending order. To find out the degree of a polynomial, again, this is now the prefix meaning poly, meaning more than one or many. If you have a lot of different terms, like x to the 5th, x to the 7th, x to the 9th, the degree of the polynomial is going to be the greatest degree of any of the terms. So this here has 5 variables, this here has 7 variables, This here has 9 variables. That means 9 is the highest. This is a degree of 9. Let's see what we mean in the next couple examples. So the first thing we're going to do is we're going to put it in standard form. Then we're going to identify the degree. So looking at these here, we look for our highest exponent first. So we have 6x to the 4th. That's our highest degree. It goes first. Our next one here is a negative x to the 3rd. Our next highest one here I see is an x squared, so it's negative 3x squared. Then we have our x to the 1st power. And lastly, we have this minus 5. Now this minus 5 here, as a reminder, doesn't have any variables, so it has a degree of 0. So to find the overall degree of the polynomial, what we're going to do is we're going to look at the degree of each term and figure out which one is the highest. So our first term has a degree of 4 because there's 4 x's. Next one has a degree of 3, 2, then 1, then 0. And because these are separate terms, we do not add them together. We only look for the highest degree. So our highest degree here is to the 4th power. So you try the next one. First write it in standard form and then find the degree. Okay, so we have negative 6z to the 6th, 16z to the 4th, 12z squared, z, and negative 1. Our highest degree overall is the 6th because that's what our highest exponent would be, or the highest degree of each monomial individually. So now that we can write things in standard form and identify the degree, we can start talking about polynomials a little bit differently. We can name polynomials by the highest degree or based off of how many terms they have. I'm going to start off with the number of terms because we've already been using those terms before. If it had one term, we called it a monomial. An example of that is like 3x squared y. If it has two terms, meaning you see two separate terms separated by an addition or subtraction sign, that would be a binomial. Think about a bicycle, it means two. Whereas if we have three separate terms and we can see them all three separated by addition or subtraction, that now is going to be a trinomial. Past that, we kind of get tired of naming them. So anything that has 4 terms, 5 terms, or 6 terms, or anything more is going to be a polynomial. Again, poly meaning many. We also can name things based off of the highest degree they have. So for instance, if we had 5, remember how we said it was like x saying x to the 0? So if you have something that has a highest degree of 0, we call that a constant. If you have something that has a highest degree of the 1st power, that would be linear. Think about your linear functions. They have a highest degree of 1 here. That's why it's called linear. If you have something that has a highest degree of 2, that is called quadratic. If you have 3 being put together, that would be cubic. You also might see it 5x cubed. If the highest degree is 4, that is quartic. If the highest degree is 5, that would be quintic. And anything more than that, we don't have a specific name for. So for instance, if we had 5x to the 10th power, it would just be the 10th degree. So to actually use this, what we're going to do is we're going to name the following polynomials based off of two things, based off of the degree and the number of terms. Now I'm going to start with number of terms because once again, that was kind of nicer. For each of these, you can kind of identify how many terms the polynomial has. So for the first one, there's just one term. That's a monomial. For the second one, I see two different terms, which makes that a binomial. And the third one, I see three different terms, which makes it a trinomial. Now I'm going to classify this off of the degree. So I look at my first term, and I have 2 x's, 3 y's, and 1 z, which means I have 6 for my degree. Because it is 6, it is the 6th degree. For my next one, I have 3 x's and 2 y's in my first term, and I have 1 x and 3 y's in my second term, but I don't add those together because they are separate terms. So the highest number I see here is 5, so this is a quintic. For my next one, I have 4 variables, then 2 variables, then 0 variables. And for each of those, now looking at it, my highest degree is 4, which makes this a quartic. So pause the video now and try D, E, and F. So D is a cubic binomial, E is a constant monomial, F is a quintic trinomial. So now we can start talking about polynomials. And what we want to start adding and subtracting these different terms together. So this one's going to be very similar to the last one. Find all of the terms that are alike and combine them by just adding the numbers out in front. So you try it and then come back here for the answer. So for your x squared, y squared, you have -8 and -5, which gives you -13 of those. You have 12 x squareds, 1 y squared, -9x, 15y, and 35. Let's go ahead and take a look at how we did that a little bit more closely. So if you have a polynomial, to write it in standard form, you want the highest degree to go first. So you're going to look through and you're going to find the highest exponent, which is y to the third. Now I see 2 different y to the third terms. So you're going to take and combine them by adding your coefficients. You get 12y to the third. Next would come y squared, but we don't have any of them, so we're going to go to the y's. So we have -5y when we combine those. And then last comes our constant at the end. So overall, we can see that the highest degree here is 3, making this a cubic function. So we can do the same thing with the next couple if you want to. Let's skip this one and go to the next one. We have 4x squared and -1x squared. So 4 minus 1 is 3x squared. -3x and +3x, those ones undo each other, so they cancel out. So this is our final answer here. The highest degree here is 2, making this a quadratic function. And for our last one here, we want to make sure that our like terms have the same variables with the same degrees. So I see an x squared y squared and an x squared y squared. We can combine those two together. 12 plus 8 is 20, x squared y squared. We have a -13 x squared y and a -9 x squared y, which means -22 x squared y in total. Oops, sorry, I dropped my squared in the first one. Make sure you do have that. So the highest degree here then is 4, making this a quartic function. So for adding and subtracting, when you're adding, this is just an issue of combining like terms. So 6 and -4 become 2y to the 4th. I have -12y squared and 7y squared to get -5y squared. 3x squared does not have anything in common with anything else. And our -3 and our 9 would give us 6. So when you are adding, you are just combining like terms. So we'll go ahead and take a look at subtracting then in part 2.